So what we'll do over the next 90 minutes is to present our new agent platform. Like Kobus rightly described, we are trying to create the new operating system for agentic applications. We'll walk you through the different components of it. Especially, we'll also try and cover what are the building blocks that we all need to create agentic applications, what are the tools that you need to evaluate, and how do you go to production with agentic applications. For some of you who already know what we do at Kore, you might be familiar with our platform in 2024. We used to call it as the XO platform, the Experience Optimization Platform, where we were primarily doing conversational AI automation. Then we started moving into search. We created a search AI platform, which is primarily for the retrieval augmented generation. Then from 2023, we also started building Gale, which was our AI engineering platform. So each of these had a different purpose. Conversational AI platform was helping you to do customer experience optimization. Search was helping you with the enterprise knowledge retrieval. Gale was helping you build the agent tools, namely the model hub, the prompt studio, evaluation, flows. Right? So while we started creating all of it, we realized that as enterprises are becoming more and more mature in how they think about agentic applications, we also transformed our platform into a new paradigm. So the tomorrow's keynote will have more details into how we went through the transformation, but this is a quick introduction of what the transformation looks like. So all of the components that we had, the building blocks, have been transformed into something called as the agent platform, which gives you the, please. Okay. I think they have to record the session, lowering the light. Can we lower the light, room light? Okay. Right. So the building blocks that we had have been transformed into agent platform. Then we also relooked at how we provide our offerings to our customers. So we created 3 different offerings on the top. AI for service is for customer experience automation. Whenever a customer calls you, initiates a chat, sends you a message, that's where AI for service will come in. It has a self-service, agent assistance, and quality assurance with the full-scale contact center capabilities. AI for work is the new offering. We launched it in 2024. Consider this as your enterprise version of ChatGPT that all of your employees can use to improve their productivity, discover knowledge, create content, automate their workflows. That's AI for work for you. And AI for process is the new offering. We launched it in last February. The idea here is all of us do multiple tasks, and very often we work with different team members to get some things done. It could be as simple as applying for expense reimbursement, or it could be processing a KYC document, or flowing through an insurance reimbursement. Right? Anywhere there's a business process involved, a workflow involved, you can transform your workflows using agents with AI for process. So those are the 3 offerings. We have breakout sessions for each of these offerings to take you in detail what they offer. But in this workshop, we'll mostly focus on the agent platform, which is the builder platform that helps you build AI agents. It's all about multiple AI agents working together. So take any example. Like say when you walk into a bank, right? You might be going there, like say to apply for a credit card. You'll go to one person. But if you're going there to get your car loan done, you'll go to another person. So you might have 1 or more employees helping you within an organization get certain things done. So you can think of multi-agent applications in the same terms. You create multiple specialized AI agents, each performing a different function. Then you assemble all of them, create a project, and deploy it for your customers, for your employees, or automate your process. Agents by themselves do not have the ability to interact with your enterprise knowledge. They cannot speak with your enterprise systems. That's where the tools will come in. That's where search and RAG will come in. You empower your agents by connecting your backend systems. We have more than 200 plus pre-built integrations, and there's a workflow builder. There's a way to write a code to connect your enterprise systems. We also have 100 plus integrations with your backend systems, CRM applications, shared drives, structured data, unstructured data. You can bring in all of it into your agent's knowledge. Now, when you have all of these, you have your agents, you have your tools, you have your knowledge. But when the user starts interacting with an agent, you have to manage the conversation context. So what is the user saying? Where do you store the conversation memory? What is your long-term memory? What is your short-term memory? What happens if the user comes back on the next day and reinitiate the same conversation? So the state of the conversation is also managed by the platform. So that's the runtime part of it. But even before you come there, right, before you start building your AI applications, there are some building blocks that you should all be thinking about. So that's the second layer of it. The first one is agentic applications by nature require you to have a language model available for you. So you have the external models, you have open source models, or you can also fine tune for specific use cases and use them. That's Model Hub. So you get the choice of models that you need using the platform. Second, yes, you have the model now, but how do you talk to the model? That's where prompt comes into play. You design your prompt, you experiment multiple versions with multiple models, figure out what works for you, start using it. But then you would have tested Model Studio for like say 10 use cases, 20 use cases, but how do you evaluate at scale? How do you evaluate on multiple criteria? That's where the Evaluation Studio comes in. Now, most of the times you'll be happy here, right? I have the building blocks, I have the tools, I'm good. But AI safety is equally important, right? Especially in the world of AI applications because of the subjective nature of the models. You need to be able to anonymize the PII data, have safety guardrails, all of that in place. So that's the safety module. Now, when you go to production, you need to understand how the applications are working. Are the agents performing the work they are expected to do? Is the model responding as you expect to do? What is the token consumption? What is the latency? What is the response times? That's the analytics framework. Now, finally, the observability is slightly different from analytics. With agentic applications, there are some challenges that you will see. In most of the programming world, the execution flow of the program is known upfront because you would have written the conditions, you would have written the logic. But in the autonomous world, the decisions are being taken by the agent. So how do you understand how the decision making happens? What were the decision points? And which path did the agent choose? All of this is important for you to scale your agentic applications for production. That's observability. Now, these are the building blocks that we have. It doesn't stop there. What we also realized is as we speak with many enterprises like you, all of us started our journey, I'm assuming somewhere in 2023, then we started improving in 2024. All of you would have probably heard about frameworks like LangGraph, Retail, Crew, AutoGen. There are hundreds of frameworks out there. So some of your AI teams might have already created agents in a different platform. So what we understand is we understand the capabilities. What we have created is agent protocol that allows you to run some of your agents on different platforms for whatever reasons you may have, but you can have the entire orchestration on our platform. So that's interoperability. Similarly, we already created our own version of tool integration between agent and tool, but then Anthropic has came up with model context protocol. That's being widely adopted. We understand, we appreciate it. So the agent protocol is also compatible with MCP servers as well. The next one, we are all learning, right? So we are very new to the entire agentic world. So we have some functionalities, some way of doing orchestration, some way of doing tool calling. But what if you need something more than what the platform offers for you? So that's where the SDK comes into play. So you're not confined by what we offer today. The SDK allows you to extend the platform capability. You can write your own custom code, test it, evaluate it, bring it to the platform. We take care of the deployment, scalability, security, performance, elements of it. Now, after you do the prototypes, when everybody says, hey, this is good, you need to deploy it for your production scale. We have the experience of working with largest of the customers, for example, with 300 million calls every day. So we understand what it takes to do the CI/CD pipeline, to create a versioning, to create the environments, to go to production. All of the tools are already available for you. Now, collaboration is extremely important aspect. We always had that capability. We carried that into the agent platform. You bring your multiple users together. Say, in all of our companies, you might have someone really very good at prompting, so you invite them to the prompt studio. You might have someone very good with creating APIs, you invite them to the tools. Someone very good at understanding the business use case, bring them to the agents. So you can pick and choose whom to invite where, and bring all of your company into the agent platform to build the agentic application. Now finally, to make your life easy, we are also having Marketplace. It's launched last week. It has more than 200 plus agents and tools. One click, you deploy into your consumption. You can deploy tools separately, agents separately, or the entire agentic application as a project into your AI for work processor service. So these are all the building blocks that the platform has. What we'll do over the next 70 odd minutes, we'll start going into each of it. Murali will start with the model prompt evaluation. Then I'll look at the agentic applications, and Param will help us with the marketplace overview. Any questions at this moment? Thank you. Your laptop. Oh, sorry.
Just out of curiosity, I think I see repeat faces here from last year's conference. Has anybody used Gale before? Experimented with the product? Okay, a couple of hands. The reason I was checking was we have a lot of stuff to show on Agentic. I was wondering how much time I should spend on Gale. Looks like quite a bit. All right, so Santosh talked about broadly the different agent building capabilities. And the building blocks of Agentic is all the blocks we have from the erstwhile Gale, which has now become Agentic platform. So I'm just going to briefly talk about the key important components in here, and then we'll see a couple of examples, and post that we'll go into Agentic. I'll start with the model hub. Now, obviously, if you think about anything related to agents, generative AI, et cetera, it starts with models. And we support pretty much all commercial models out there. And configuring commercial models is pretty easy. You can add a model, select a provider, provide your API key, and then those are already integrated. Now, this is the easy part. I mean, obviously, commercial models are the easiest ones to set up. By the way, we also have API integrations. So if you have a model that's running, so in some scenarios where we've seen with our customers, they have commercial models, but they're not directly using an API key. They probably have that running on their server somehow, and then you're integrating with them. Or for other purposes, you may have your own custom models that you're running on your servers. You just want to use them within Gale, Agentic platform. And then you just have to say, well, custom API integration, provide the API parameters, and then you're good to go. That's the external models. Obviously, the open source models are becoming stronger and stronger. We see a lot of use cases that's now possible for you to actually have simple 14 billion parameter models or 24 billion parameter models doing the job. You don't have to go to heavy lifting models such as 4.0 or O3 mini for you to do some simple stuff, which means that you have to bring them, have them available for you to use them. We provide a way for you to deploy open source models. Now, you can either use any of the open source models we already have predefined configured and deploy them, or you can go to Hugging Face, establish a connection with Hugging Face, give a particular model name. We will import that model from Hugging Face and have that deployed on the service for you to use. The deployment process is pretty simple. You actually select the default parameter settings. This is useful if you want to use the same settings across multiple instances of this model, but that doesn't mean it's fixed in stone. In every instance, you can configure that again if you want to modify that for that particular instance only. Then where do you want to deploy the hardware configuration you want? This is important because depending on what the use case is, what the throughput you're looking for, and the latency requirements, you want to select the right kind of hardware. We tell you the base minimum hardware required for you for a given model and the parameters of that. But obviously, you can select any others that's available. And obviously, depending on where you have this installed, the configuration of these available GPUs can be depending on the hardware capabilities of that installation. And finally, you have this whole piece of information that you can review and then deploy the model. Now, you have commercial models, you have open source models. In some scenarios, you actually want to have your own models. Now, we enable you to fine-tune models. Fine-tuning the model essentially helps you with obviously cost, second with latency, because if you want a specific kind of model which does a very, very specific use case, you can take a tiny model, probably a 2 billion, 3 billion parameter Gemma model, and fine-tune that for a specific use case. So obviously, you'll be able to running that on cheaper hardware and get a very, very efficient latency. Yeah, I think they wanted the opposite of that. No, lesser. I don't know. Is that better, by the way? I know. Oh, sorry. So when you're thinking about fine-tuning of the model, you start with the base model. And this base model, again, can be any one of the model we have hosted, or you can import that directly from Hugging Face. You provide some fine-tuning configurations. You provide a data set. And then you also can provide a separate data set for evaluation. Once you have selected a data set, you have an optional test data set that you can provide. So the model will go about, the tool will go about fine-tuning the model. Once the fine-tuning is complete, it will apply the fine-tuned model on top of the test data set for you to be able to see if the model has done what it's supposed to do. You obviously have to provide the hardware upon which fine-tuning is going to happen, very similar to model configuration deployment. You provide the hardware, and if you do have weights and biases as your application to review the model configurations in your organization, you can connect to weights and biases, and we will push all the fine-tuning data directly to that particular application for you to use that in your downstream activity as you've always been doing. That's really the foundational piece for everything in the platform. You need the models for everything to work. Now I'm going to jump on to prompts, but very briefly I'll pause to see if you have any questions. Good. The next and most important piece is really the prompt. And we've been talking about this. We have seen the evolution of where you interact with the computers, from writing assembly language to the modern languages such as JavaScript, React, or Python. Now, what we have moved on from there is really, every step of the way we've had various different levels of abstraction. Essentially, we're getting closer and closer to how we actually communicate with the computers. Rather than trying to learn how they understand stuff, we are making them understand how we speak. And now we've come to prompts where essentially our conversation with the computers is basically natural language. Not only English, you can pretty much talk to that in any language that you know, and they respond accordingly. What that also means that everything you build in agentic/generative AI applications are defined by how well you craft these prompts. They become the code of modern applications. The erstwhile applications, you had to write significant amount of code in whichever the language you chose. Here, you write code in English, and you write them in such a way that the models will actually respond to what you need to, which means that you need to be able to figure out what kind of prompts you need to write and how well the prompts are working against a specific model or multiple models, go through the process of evaluation, and get all of them done before you actually start building the applications themselves. I'll wait. So in the Prompt Studio, we enable you to create a full prompt experiment. You can start with a prompt experiment, and when you get in, writing prompts can be quite hard. So what we have done is we have created a Prompt Studio that focuses on entire lifecycle of a prompt. I'll explain what that means. Well, the best way to start writing a prompt is to see an existing prompt that's been crafted for different type of models. Now, this helps you to figure out how a particular prompt has to be done, how detailed should it be, and we have curated about 70 different prompts. We'll continue to improve on that. You can select any one of these prompts and say, I want to use them as a starting point, and then customize that. Now, that's the first way of doing it. You can go look at existing prompt library and then use it. The other way of doing it is basically giving the model and say, you know what, write me a prompt to generate SQL queries, K1 RDB schema. Now, you're using the model itself to help you write better prompts, because obviously it knows what it understands, and it can help you craft the prompts better. Now, that one sentence, typically what we do is when we are interacting with these models, whether it's ChatGPT or anything else you use, you actually give them simple English statements. That may be good, But if you want to really tailor the model towards how exactly what you want the output to be, you have to be exhaustive in your prompts. And this helps as a starting point. Now, the next step here is that once you've crafted this prompt, you want to do a very quick test. Now, obviously, here, this entire prompt studio gives you the ability to select and run these prompts across multiple models. Let's say I select 4 on Claude. Now, I don't have any test data set yet because I'm just creating and experimenting very early stages to see if this works. What I could do, this particular prompt we generated, or the model generated, actually has 4 different variables. Now, I can provide data for these variables and then run them against all of these different models. But initially, creating a data, it's also challenging because I've not really curated anything. I can say, okay, use the concept that you already have and generate a bunch of data sets for me. Now, this basically looks at the entire prompt you've generated, looks at the variables in that particular prompt, and then it generates a test data set for me, which I can just apply and say, I'm going to use that for now because I just want to see if things work and this prompt is okay. And then I can run this across various different models. Now, pretty much I've asked the model to do everything for me, right, from creating the prompt itself, generating a test data set, and then asking the model to run itself and see how I compare against each of these. So I have 5 data points, and then I can compare them and see how each one of them is working, including the tokens, the latency, et cetera. One of the things we are working on is trying to bring the evaluation capability that I will talk about in a second into the prompt studio, but we don't have that currently. Hopefully, in about a month, we will have that. But evaluation studio exists, so we'll talk about that in a second. Now, this is extremely useful because one of the things we realized over a period of time is that as prompts become the way you communicate with the models and hence the computers today, you want to really safeguard this and provide a lifecycle around it, just like the way you would do with code. You actually check in, check out the code, make sure that's centralized, and people who are writing actually know what they're doing, and then finally you use that in applications. Similarly, with prompts, we have created a lifecycle where I'm okay with this now. What I can do is I can create a commit. Once I create a commit, this creates a version, and the version it creates is immutable. That means now it actually has an API endpoint that I can go use any application that I want to, and then this API endpoint will always promise to give you exactly the same prompt anytime you request, irrespective of how many applications request this. Now, this API endpoint also takes a version name, a version number as a parameter. You can choose to ignore that. If you ignore that, every time you call this particular API, it will always give you the latest version. People can be experimenting with it. They may create a new version by doing some modifications in the prompt and commit that. You'll end up getting the latest version. But if, let's say, you're building an application and you always want the version you ensure that you have experimented with, nothing else, you send the version number in your API request, and it is guaranteed to return the same version all the time. And obviously, if you want to experiment with structured output, we provide the JSON schema. We'll talk about that another time, but that gives you a way for you to define what the output should be, forcing the model to respond back with the structured output. Now, we have this entire aspect of, so you saw the prompt library earlier. That is predefined prompts that we provide you out of the box, but you can create your own prompt library once you start experimenting with it. Once you save them, you have your own prompt library. In the prompt library, you'll have your own My section, which will have these prompts that you have created available. Obviously, the prompts can be shared with other people, and then they can collaborate with you, et cetera. Now, you can actually continue to add multiple models. Earlier, when we had the prompt version, every time you change something, you had to run pretty much everything. And we realized that, well, first of all, it was time consuming. Second of all, because you're experimenting in the early stages, you're also consuming tokens. We didn't want to do that. So I can go back to the same thing and say, hey, new model, come in now, and only run this particular section. So I can have only that model run against this, or I can change one particular row, add a new data set, and just say that row, execute that, and see how things are running. So you can see all of this is happening, and now this helps me doing a full comparison of exactly what's working. And when we bring the evaluation studio, the comparison is not basically me saying, hey, I am reading this, I'm reading that, but instead the model going and say, this is better than that because of the criteria you actually define. That's Prompt Studio. Any questions? Okay. This is quite a group compared to the last one. All righty. Oh, there we go.
As we start to give all the employees their own agents and their own agent building blocks, can we do this like Legos where we restrict them to ones that are pre-built that already are on our configured protect our data sources internally or the pipelines?
So if I understand the question correctly, you're saying that I have a pre-configured data set. I want people who are actually experimenting with the prompts only to use that data set?
No, I want the employees to be restricted in which Lego blocks they can use to build their own agent.
Yes.
So
Yes.
if an employee wants to build an agent for doing their expense report, we got one pre-built for them, they can only use that one, they don't create a new one.
Yes. We have a comprehensive user management capability where everything, first of all, every account is a sandbox. Within that, you add users. For each of the users, you give specific permissions for each of the different modules. It can be view, edit, admin, et cetera, Thereby, you have full control of exactly who's going to be able to use what part of the application.
So if I get the prompt module, it's restricted, I can restrict it to just our data set.
Exactly right.
And that's the only prompt module they can use when building their own agents.
Exactly right.
Great.
Okay. That's prompts. Now, what I want to talk about is agents. Oh, agentic tools. It was earlier called agents. Santosh stole the thunder. I will talk about agentic. So what we are working on here, there is actually multiple levels of complexity, and it's important for us to understand this. Now, if you think about moving from a simple way of traditional application development to agentic application development, you probably are on a path of incremental autonomous capability. You may want to start with something simple, saying I'm going to use a model randomly in between my flow, and the model takes the input and provides an output. But eventually, though, I want to go and give the model a little more autonomous capability, where I'll provide tools, where instead of me defining the decision-making process in the design time, I'll let the model make a decision in the runtime. And then eventually, we move into complete autonomous capability, where I provide the orchestrator an agent and let the orchestrator decide what agent to trigger and the agent to decide what tool to trigger. And when you're thinking about all of this complexity, it's very easy for you to build smaller agentic application that goes and gets some information from the web. But in the enterprise context, you're probably doing a lot of different activities. Within that activity, you may have certain aspects of it that is definitely deterministic. You know it has to be A, B, C, and there may be some part of it which is probabilistic. So this entire workflow capability that we have enables you to build a flow that makes sense to you. So we provide a lot of different nodes here. The AI node, we provide multimodality here. You can have text-to-text nodes. You can have text-to-image nodes, depending on the model you have. You can have audio and image-to-text as well, which actually does the OCR behind the scenes. So if you have a PDF that's coming in, if you want to extract content out, et cetera, et cetera. We also have integrations. I'll show you the integration at the setting stage, where you have to configure the integration that's available. We support 200+ integrations with various different systems. That helps the models and your workflow to communicate with them. So the integrations provide two different purposes. One is what we call a trigger, and that is what we call an action. The trigger is, I have an integrated, let's say, with HubSpot. The trigger helps me if some event happens within HubSpot, then we want to do something within our application. That's a trigger. Because that event happened, we will do something here. Action is that after we finish doing something, we want to push data back to HubSpot. So you have both kind of capabilities, depending on which integration you have. A trigger lets you see what's happening in the source system, and then based on that, react to it. And action lets you push the data from here to the source system. Now here, this particular flow that you're seeing here is actually taking an input. And by the way, this will be part of the agentic application that Santosh will speak about in a second. Now, every application or every workflow here will have an input node and an output node. This defines your contract for the API. So once you actually deploy this particular flow, the API endpoint will expect this input configuration you've done as an input to the API, and whatever you're configured here as an output will be part of the output configuration. Now, what this flow is doing is basically it's going and looking at the database schema, because this is going to be a part of the agentic application. So think about when we have built all of this complex flow. Now, that flow is given as a tool to an agent, and the agent is executing this in real time. So that we will touch upon. But when it provides you some kind of information, what this flow is doing is it's basically going and retrieving a DB, because it's supposed to go execute something against a database to respond back to the user's query. For it to execute against that, it has to understand what the data schema looks like, generate a SQL query, and provide the SQL query back to the agent, so the agent can execute the SQL query and get the response back. So here it is getting the schema. Then we are using a model to generate the SQL query based on the schema. We are validating if the query is right, and if it is right, we are sending it back to the agent. So once you go in, I mean, obviously we have other nodes, API nodes, which basically lets you connect to APIs. Doc search, our RAG implementation with Search AI, it enables you to look into a collection within our RAG and then use that piece of information for anything that you want to use in the flow. For example, there may be an input, and I may know my entire knowledge base for my organization is out there, let's say HR knowledge base or SOPs, and you want to touch upon that knowledge base, extract out the information, go to the rest of the flow. You can directly integrate that with RAG. Function nodes are plain simple functions you can write in both Python and JavaScript. Now, historically, we've had limitations with the libraries you can use here, and that limitation is for security reasons. We have purposefully limited that because you don't want to really enable malicious code to come in and disrupt what's happening. What we are working on right now, though, is enabling execution of code in a sandbox outside of our platform in real time. With that, we will have almost no limitations to what kind of code you may write, and thereby enabling you to do stuff that you need to do with the libraries that you want to, and still have all the capabilities that you have within the platform available. And the reason we are going towards that is quite interesting, because we are experimenting. Right now, you will see that the agent will provide tools to the agent for it to execute, but eventually, we would want the agents to write tools and execute at real time, and for it to do that, it can come up with any library. So we want it to be happening in a sandbox. At the same time, we can extend the same functionality for you to be able to write code too. So that's broadly about the flow. Now, so when you, obviously, if you go back and take a look at the monitoring, so this gives you a full observability of every particular run on this model. So for example, this particular flow has run how many ever times, total 12 runs in this week. You can see that response time was about 3 seconds, generally at 99.4 seconds. You can go to each run and now see exactly what happened every node. So for example, in the DB schema retriever, this is what it actually came out. You can go back and see what happened in my query generator node, what was the prompt that was sent in, and essentially what was the output that came out from that particular prompt. So you can look at the output. You can actually look at the raw request and raw response. Now, this gives you an idea of exactly what's happening, gives you a full control of what's happening at every run, and be able to debug that if necessary, if things have failed for whatever reasons. Now, this is runs. We also track every model execution. So this model execution is only for this particular workflow. We have broader model execution across the account. I'll show that in a second. But this basically says, OK, I've called GPT-4o multiple times, and each time, this is a request that went into the particular model, and this is the output that I actually got out of the model. And this is useful for you to see if model execution failed for whatever reason, especially if you start using your custom models and smaller models, what exactly happened, and how to debug it from there. And then once you're ready with all of these, you can deploy this particular workflow. And once you deploy this workflow, you'll have an API endpoint, an API key, just like the way you would consume everywhere. Now, that's available for you to consume from any other application you would want to. And you can have the API as a sync or an async with both pull and push. Yeah.
So in Gale, we were using word agent, but today I'm hearing tool and agent. So definition-wise, what's the
Yeah. Yeah, we decided to confuse you a little. The tool is the workflow. Essentially, the reason we call it tool is, by the way, this is all going to change a little. There are two ways that this workflow is going to be used. One, you can call them directly. It's a workflow if you call it via an API. Second, we provide it as a tool to an agent. That's why it's called a tool as well, because you build complex flows and then you give an agent this flow to execute it whenever it sees fit. That's why it becomes a tool. So depending on how you use it, behind the scenes, it's exactly the same functionality. So if you're using it with agent, it becomes a workflow tool. If you're using it directly, it just becomes a workflow.
So agent is kind of a runtime engine now?
Agent is what Santosh will talk about. Essentially, that's our entire agentic AI capability, which is autonomous agents, really. Okay. Quick check on time. How are we doing? Which is, I have 50 more minutes. That's a big can of worms. Let's talk about that. Now, if you think about it, there are two kind of protocols that are coming in the market. One is MCP, another is agent protocol. So MCP, if you really think about it, a very, very simple way, it's a wrapper on top of APIs. So I can provide, instead of me actually providing specific APIs for the models and the agents to go talk to, I can basically say, use this MCP, and the MCP gives you the instructions of what the capability of the API is. Essentially, MCP service gives that. And the model can use that information and figure out what particular contract within that it has to call, and then it will execute that and get that information. So alongside agents, where we provide tools, which are workflow tools, code tools, we'll also enable having access to MCP tools, which hence it can interact with any MCP servers that's out there in the market for it to get the information that's necessary. Currently, well, it's in QA. We'll be there soon. And the agent-to-agent protocol is a completely different beast. I mean, we've been working on the agent protocol. Obviously, one of the fundamental things in everything we build, literally everything we build, is that we know we work with enterprises. And enterprises already have existing systems and processes at play. And everything we build, we want it to coexist with what they already have. From that perspective, we started working on agent protocol a while ago, but now with the Google agent protocol, we have an extension to that. Most of that is similar to what we have built, and we will also abide by what A2A is from Google, enabling people to write agents in their own environment, in their own coding tools, frameworks that you're using, but yet coexist with what we have built, and then work together to execute larger tasks and objectives. Still visible? Yeah, so agent-to-agent protocol and MCP. I mean, those are the two things that we see today. Things may change, things may not, but we are all on top of it constantly and evaluating that. If a new protocol comes in, we'll probably support that too, with a simple objective of saying we want to coexist with what's there in the market. Now, that's tools. Any other questions? I want to jump into Evaluation Studio for a few minutes and then hand it over. Okay. I'm going to talk about Evaluation Studio broadly, and we can go into details of this. I have a separate session coming up day after tomorrow. Now, the whole point of Evaluation Studio, by the way, comes from the belief that, like the traditional application development, which is focused on test-driven development, we believe agentic will be evaluation-driven development. The entire aspect of building agentic applications from the ground up has to be driven by evaluation. You should define what your objective is. You should define your test cases. You should test them often across the early part of it while you're doing the experiments, or just before production or after production, and keep on ensuring that the model is doing what's supposed to do and the agent is doing what's supposed to do. With that in mind, we actually built the Evaluation Studio that provides you these capabilities. Now, for you to evaluate something, you need a data set, and depending on where you are in the life cycle, the data set can come from a test data or a synthetic data or from your historical context. Let's say, for example, you're testing the capability of your agent here, call center agent and customer interactions. And there may be a lot of transcripts from call center conversations. You may want to bring that as a test data to begin with and test it with models. Same thing you can do in Prompt Studio with the models, and then here you can start doing it with agents or your agentic applications that you have developed. Then when you go into production, as I showed you, we trace every model input output. So you can import all your production data into Evaluation Studio and apply evaluators on top of it. So evaluators can be AI evaluating other AI. Evaluators can be you writing custom functions. So for example, I want to see if it's generating a certain type of output, and I want to write a simple regex expression with Python, you can write that and apply that as an evaluator. Or in scenarios where it's extremely critical and you want it to be reviewed by humans, then you have human evaluators where essentially people can go in and say, this is the model output, I'm okay with that, not okay with that, rate that, etc. I'll talk about what these look like in a sec. But we have a data set and we have the evaluators. Sometimes you need context for the model to work, and the context can come from a RAG implementation. A context can come from an API, because not only would you have your test data has to be sent to your RAG implementation, the output of that has to be further evaluated. That's where we have this dynamic content capability, where you can bridge the gap with APIs and Search AI, and I'll talk, you can also test other prompts as well. So let's go into how it looks, and then we'll talk about questions. Now, because we think this is a full life cycle, you can create projects, and within projects you can have multiple evaluations. So for example, here's a contracts management, which is a agentic app that we are working on, which has multiple evaluations. One of the evaluations is RAG evaluation. Once you go into an evaluation, then essentially it's like a spreadsheet. You can continue to add as many evaluators as you want to, and we support various different type of evaluators, whether it's quality evaluators, safety, or RAG evaluators that's available out of the box. And once you add them, they become columns for you to evaluate. You can write your own custom evaluators if you want to, essentially using a model that's available or any custom models really. And you can define the model parameters and the description of that evaluator. And for you to get a starting point, we give you a template saying, okay, maybe the groundedness is my base template that I want to use in, and then customize that, the evaluator on top of that, so you can do that. And once you have an exhaustive prompt defined, then you have to say, well, which column am I evaluating? In this particular scenario, input may be the user query, the output may be a generated answer. Those are the two things that I'm evaluating. That depends on how you've actually written the prompt itself. In the prompt, I have two parameters here. If I didn't have this parameter, then I would not have to give that a column reference. Now you have provided all of this, but then you have to say, well, what does success mean? You can define the success in two ways, either as a score or as a boolean. If it's a score, then the application needs to know, is 4 better or is 2 better? So you actually define saying, okay, if it's greater than 2 or greater than 4, consider this to be successful. Or if it's less than 2, consider this to be successful, depending on how you have written the prompt and what you're doing. And if it's boolean, then there is no need for us to give that, because we know true and false or pass and fail. Any questions? I still have a few things to talk about here. Any questions so far? Okay. Now what's happening here is we have a bunch of user queries, and this is essentially a shortlisted chunks that has come from RAG. Given this query, the Search AI has written these chunks, and then this was the generated answer. So what we are trying to evaluate here are multiple things. One, we want to see if the extracted chunks are relevant to the question that's been asked by the user. Then we can say, is the generated answer complete in the context of the question and also in the context of the chunks that were retrieved? Is it actually using the information that was retrieved, or is it hallucinating with more information? So you can pretty much add on any kind of evaluator you want to. So for example, I can say hallucination here, and then use that particular evaluator and say that's what I want to evaluate it against, wherever I see. Okay. Then you have groundedness, you have fluency, and paraphrasing and completeness. So these will give you a different type of information about what is that you're trying to evaluate and how they look. Now, as I said earlier, you can also have human feedback. Now this gives you 3 different types. You can just say thumbs up, thumbs down, the simple ones, where you say, okay, this is good, not good, I'll take it in, or suggest a better answer. This is extremely useful if you are testing your fine-tuned models. So because we have an ability for you to run prompts here, which I'll show you in a second, you can actually have a fine-tuned model come here and do a batch testing on top of the fine-tuned model with your test data set. And then you can have people going and saying, well, the output from the model, is that good enough for my scenario or not good enough? Let's say, for example, your fine-tuned model was for summarization of some conversation between a customer and an agent, enterprise agent. Now, you want to make sure that summary is appropriate to your enterprise context. If you give it to ChatGPT, it will probably do some random summarization, missing out the key information such as account number, for example. Now, here you want to make sure that it is actually not only summarizing the English part of the conversation, but also extracting out the pieces of information that makes sense, because that's why you fine-tune the model in the first place. So here, somebody can go and say, okay, this is actually doing the job or not doing the job, and you can use that piece of information for you to fine-tune the model again if you need to, or refine the model itself. Now, as I said, you can also run prompts. This is useful if you have fine-tuned model, as I was saying, where you say, okay, I'm going to run the fine-tuned model. Every model configured is available. And you can say, use this particular column, run this. And then this gives you the ability for you to do significant amount of batch testing. With Prompt Studio, you are doing very early part of the testing. When you go on into the later part of your agentic app development, you would want to do comprehensive testing, and that's where this comes into play. And you can actually do bring in several hundred rows of data and then execute them. Any questions on the evaluation? Yeah. So output generated from the model, you want to use that to
validate against my tool. Now I see how the tool is performing.
Tool data.
After the
Okay. So let me understand this. You have an output that's, let's say, an agent runs or a workflow runs, and essentially there you have a model performing some action. The model has generated the output. I'm going to use that output now, and then I'm going to apply that to test my. What are you testing against?
So I'm expecting output in a certain way, right?
So when you go in, for example, right now where we were in here, you could actually provide the ground truth, right? If that's what you're talking about. The ground truth is a column where I've actually defined for this query, because I have created this test case. This query, this is the actual ground truth. Now, when you're comparing here, you can compare it against the ground truth and generated answer and say how close is the generated answer to the ground truth. That's the evaluation. And that helps you, and this is very important, you're right, because if this is a mission critical application, you want to make sure the ground truth is clearly defined. That becomes your test case, and then generated answer can be compared against that and see how close it is, and is it actually capturing the information it's supposed to. So,
is it at the model level or at the tool level?
Sorry?
Is it at the model level or at the tool level? Like the tool may have multiple steps, right?
So there are two types of evaluations. One is model, another is agentic. We call that semantic evaluation and behavioral evaluation. Semantic is testing the capability of the model. Is the model doing what it's supposed to do? Behavioral evaluation, which is about agentic evaluation, is something that we right now have in QA, will be in product very soon. But the focus there is not just model. Focus there is the tool calling ability, agent calling ability, end-to-end completion, trajectory, all of these pieces that actually says how well the entire agent is executing from the overall end-to-end goal to very specific tool calling, and within the tool calling, did it actually call with the right parameters and the right value, et cetera, et cetera.
So we're running a lot of our intents over scripts, and can we use the evaluation model to make sure that it's based upon the intent that we're receiving, it's flowing correctly, and it's gathering correct intents? Can we use that outside of like an LLM or anything like that, just on based on the script writing?
So if you have a script, if you already have an input and the output that was generated there, you can bring that input output here as two columns, and then use any model or the evaluator we already have to apply on top of that, see how they're doing. So all you have to do is, wherever that is, let's say for example you have intents, and you want to see if the actual model recognizes the intent at the right time. So you have both the input and output, and then you probably will have a ground truth as well. So you just export that data from there into a CSV, bring it here, import that. That becomes a full list of rows here, and then you start applying the evaluators you want to on top of it. So pretty much what you see here was actually imported. So let me actually quickly show that. So if I create a new evaluation, I'll say demo. So here you have to look for where the data is coming. What happens here is you have two options. One is you can import the data from your exported spreadsheet, or you can say import the data from production. If the agents are running in our system, then you can basically say which model do I want to import the data from, which source, is it all tools, all prompts, all executions, or a specific prompt or a specific agent, and then when do I want to import the data for, and then whether it's importing input output. So then you're actually going into the production data and importing it. By the way, on top of this, you can also automate this, where you can say, I'm going to build an evaluation set, but I want the evaluation set to run on the model output every day or every week. Then behind the scenes, it automatically runs the evaluation on top of the model from the production data output, and then keeps on telling you how it's doing. When you see a drift at some point in time, you've got to go back and say something is wrong, I may have to change.
And here the source can be search A or the source of the data.
Source of the data, here there are two sources of data. One is you have a data already in some kind of a file, CSV, you want to import it, or the data in the production. If you want to bring it from Search AI, that's where we have the Search AI column for. When you go in here, we have this Run Search AI column, which basically, once you configure this, you can say, okay, which connection, I mean, obviously you have to have a connection for the Search AI, which collection do you want to do, and where is the query coming from, which column is the query. Then what it will do is it will take that query, execute on Search AI, gets your response, and then you can do whatever you want to do with the response. Okay. Does that answer your question? Sure. All right. So I'm going to, a couple of things I'm going to touch upon, and then I'll leave that with Santosh. Obviously, the user management, et cetera, et cetera. I talked about integration. We have plenty of integrations available. Excuse me. Each one of them with different capabilities, et cetera, and you can take a look at that. Then we have analytics. Every run of every agent, every workflow, et cetera, are tracked here. You can see, for example, there were 4 tools, total 95 runs, and number of nodes executed, how many nodes were executed, what was the average response time. You can look at it by a particular flow and see what's happening, number of nodes executed. So this is from a workflow perspective. I can look at it obviously by timeline. Then I can go to model execution. I can say how many credits are consumed because it's a fine-tuned model. But if I go to external model, you can see how many tokens I've consumed, what was the model latency generally, and how many number of requests that were taken into consideration, et cetera. And you can choose that by model and see exactly what's happening in each one of them. So this gives you a complete overview of exactly what's happening in the platform. But the important piece is also model traces. Now, when everything that we have everywhere across all the applications that you have within the account, we capture all model traces, and you can go to each another model and see exactly what's happening for each model trace. You can go look at what was the input, what was the output, where the request came from, what was the base model used, response time, who triggered the request. If it's an API key, you will see it was the name of the API key that was actually triggering the request. In this particular scenario, I triggered the request from Prompt Studio, and I triggered the request. So you have full details of this. Now, this is important. I mean, obviously, you can see the JSON request. You can go through every trace and see exactly what's happening. What we have seen is that when you start using powerful models in the early stage, and then over a period of time, you know that you have enough data the powerful models have created. So you can do model distillation. Use the powerful models as a teacher, take all of these model traces, and then export that and do a fine-tuning of a model using this data. Then you can probably get a 5.4, which is a 14 billion parameter model, to work specifically for your context. You don't have to. You can have better latency and reduced cost, thereby having specific models and no reliance on external models. It may not work in every scenario, but this gives you an ability for you to go look at the traces, use that as a data set for you to do the fine-tuning, and then apply the fine-tuned model on your particular use cases. So that's most of the important stuff. Any questions? Actually, the interesting part is coming up next, but it was the boring part, this one.
What are the licensing model?
Huh? For? It's all part of the platform. Yeah.
Sorry, I'm not sure if you're already covered Search AI. What's Search
Oh, now, I mean, slowly and steadily, we will have everything as part of the agentic platform. So that's it. That's why it's doing that. It's coming. I mean, this is basically yesterday night. Even today morning, I saw that and say, oh, that's interesting. We are slowly bringing in all the integrations because agent, I think as Santosh touched upon earlier, agent platform is the core, and we have 3 different services sitting on top of it. All right, over to you, Santosh. Thank you.
No, no, no. Oh, okay. Okay, so we looked at all the building blocks required for building the agentic applications, right? So we looked at how to connect to models, how to interact with the models by writing the prompts, how to think about your business workflows for creating a workflow, how to evaluate all of it. Now then, how do you put all of them together? Right? So when you create a use case, like we discussed, for process, work, or service, how do you bring things together? So that way, that's where you create agentic applications. So for every agentic application, the first layer is the orchestrator. It's kind of like a manager which connects to multiple agents that are doing different tasks. Within the orchestrator, there are 3 different functions that it does. First, it looks at the question, understands how to process it. Does it need to break it down? Is there a way to further get more information from the user? Is there a disambiguation required? All of that. Once it has the context, it will break it down into multiple steps and identifies the plan in which it has to be done. So can I perform both the tasks together? Is there a dependency on between the tasks? How do I do it? All of the planning element of it. The last one is reflection, which is when the agents complete their task and give the response back to the orchestrator, it will reflect upon to see have they done the work correctly or not, right? If you have 1 or more people working for you, then you would relate it. It is almost like you managing your team. When you get a request, you assign it to different people. They go do their work. They come back, submit the report to you. You review it. You give feedback. So that's the idea. So that's the orchestration layer for you. So the next step would be you start creating specialized agents, right? So for example, if you are creating an assistant for automating banking use cases, you might create an AI agent that takes care of all of the credit card requests. When a customer asks for resetting a credit card PIN, applying a credit card applications, you could package all of it into one agent. Now within an agent, you also have to define what is that the agent is expected to do by defining the scope and the instructions. So that sets the base for the agent. But then agent by itself does not do anything, right? It needs to be taught of how to do certain things. When the user says, how do I apply credit card? You don't want Claude to directly answer it. You need the answer to come from your enterprise knowledge base. That's where the knowledge piece comes into it. So you have the agent, you define what it should do, and then you're telling how to do it. Now, customer is happy. He said, I understand how to apply, but I want to apply it now. No, you don't want Claude to apply it for you. You want your banking system to be invoked. So that is where to do the action. That's where tools come in. So you have the task to be done, you have the knowledge to be learned, and then the actions to be performed. That's every agent for you. So like that, you start expanding your agents. Like say, you have one for credit cards. You could have, let's say, another for managing insurance claims. So you create multiple different agents, and you package all of them to the orchestrator. Now, because like Murali was covering, we also support agent protocol. Even if you have built an agent on another platform, we can go and orchestrate with an external platform as well using the agent protocol that we have launched. Now, there will be scenarios where an agent has to speak with another agent to get additional context, right? So that's the agent-to-agent communication is also supported. An agent can also speak with an external agent. So that's the paradigm of agentic applications. So we looked at the building blocks. We looked at how to assemble all of them. What we'll now do is the 2 things we'll do. One, we'll quickly create a new agentic applications to see how it works. Then I'll also show a demonstration of a full-scale agentic application to understand the building blocks. Any questions at this moment? Okay. So what we are now looking at is the agent platform. So agentic applications is all of your projects that you can think of. So when you start creating an agentic applications, you start by creating a name. It's almost like giving a name to your project. So I'm creating a research agent that helps me do the personal research for me. You can pick any model that is available in your environments. You can pick and choose what works for you. You create an app. So basically now you're creating an app, which is the orchestration engine. Now when the orchestration is done, you start creating individual agents to it. So this is I wanted to go to website, internet, get information for me. So I'm calling it as web research agent. So you describe the function. And because we allow the model flexibility, you can choose a different model for orchestration and another model for agent. So you get the flexibility of choosing what works for you. So now you created the persona of the agent, then you describe the task. So this is the next step of what you do. Understand the input, break it down into tasks, and perform the task using tools. If you have more instructions, you can add all of them. And if you want to bring in your enterprise knowledge, you do it. But in this case, because I want it to go to internet, I'll add a tool called web search tool. You can import from the library. So the web search tool is similar to the tool that Murali was explaining, where you have a structured flow of making API calls, AI calls, functions, conditional logic. Everything can be done inside a tool. The tool is already configured. So just review what you created. So you can see the summary of what has been done. Now we are ready to start using an agentic applications. It's as simple as it. With a few steps, you will be able to create your first agentic applications. Now this is where you can simulate to see how it is performing. Then we'll come back to the entire left navigation. Let's say the user says, I am interested in Google Agent Protocol. Oh, is it? Is it better? Okay. That's a more complicated AI agents and agent applications. So user is saying, I'm interested in agent protocol, AI agents and agentic applications. And it says, will I learn anything if I go to Core Reimagine event? I hope it will work. Let's see. So what now happens is, as we discussed, the input has come. Now it goes to the orchestration engine that understands how to do it. It will break it down to the individual task. Now then it will assign to one of its agents. Now in this case, the website agent. Now the website agent also does its own action on what is to be done. It's reasoning upon how to perform the task. Because it has a tool to do the web research, it has invoked the tool now. So tool breaks down the question into two parts. One, to understand what is agent protocol, AI agents, and it gets back the response. Then it also made another tool call, this time to understand what is Kore.ai Reimagine event. Now both the tool output is available for the agent. Now the agent has submitted its response back to the supervisor. Now the supervisor is reflecting to make sure that the agents have performed their task correctly. When everything is done, it will come back with a response and it will start presenting you. It says attending the core will be valuable for learning AI agents, agent applications, and agent protocol. So that's how you can think about it. Now, the way we break it down, the orchestration layer, the agent layer, and the tool layer will allow you to give the flexibility of what you're trying to build. Any questions at this moment?
Yeah, the web search tool, right? It quantifies. Is it?
Yeah. No. So if you look detailed, so first time it searched with the query, Google Agent Protocol, AI agents, because the question was complex, it broke it down to two pieces. So we first did one research, it got the results. Second time it only called with Core Reimagine details. Because you don't want your web search to have complex data, right? So it breaks down. that will be done by the orchestrator, passes to the agent, and agent makes the decision. Now, what we'll do is, okay, I didn't get to show, but what also happens is as the response gets generated, the thoughts that the supervisor is making, the agent is making, or the tools are returning is also presented. This is especially helpful for employee-facing use cases because, like, say, if I go ask something, what was the last discussion I had with a customer? Are there any follow-ups? Then maybe you're going to meetings, Zoom recordings, right? So while you're waiting for the agent to get your response, the thoughts will tell you what exactly it is doing so that you have more confidence to make sure that the agent is working as expected. So this is how you build agentic applications. Now what we'll do is we'll quickly take an example. So this is another example. Most of you would have contracts signed with different vendors, right? So every time you sign a contract, the contract is in different format in terms of the PDF. The information could be the same, the contract details, the value, expiry date, but the way it is structured is very different because these are all unstructured documents. So in this example, what we have done is we took like bunch of PDF documents with different contracts. We have done two things. With the first agent, which is the research agent, we looked at every PDF and create a structured database saying who is the vendor, who is the supplier, what is the value, when is it getting expired, what are the products and services. That's one part. Now the second part, because a lot of subjective data, for example, the exit clauses, it's like unstructured content that is available, right? We took all of it, added to the vector index. That is step one. Now whenever a user asks a question, what we also do is for that input, we determine whether to do a SQL query to get the details or go to the knowledge, come back and generate a response. So this is the example that we'll see now. Let me go back to this one. So these are the three different agents, one for research, one for insights, one for RAG. Now, within the agent, when you go into any of these agents, you will see its name and description. What is it expected to do? What model should it use? Then as part of the definition, you have the full scope of what exactly it should follow. Think about it like your standard operating procedure, how you define, that's where you start writing your instructions. And then if you want your agent to have knowledge of your enterprise knowledge, you add a knowledge base and you give access to the tools. Now this is a classic text to SQL tool. So when you go to the tool definition, you can see the complete flow that Murli was explaining a few minutes back. Takes the user question, converts to SQL, and yeah, please. Sorry? Right. So we have a full-scale knowledge platform that allows you to bring data from your enterprise sources. So there are more than 100 plus connectors available. CRM, CMS system. So you can connect any of these. For example, you could connect to ServiceNow and choose how you want to authenticate and what kind of content would you like to ingest from ServiceNow. Knowledge articles, tickets, anything that you have there, right? So you bring in your data, and then you go through the extraction pipeline to get all of the data into the vector index. And there are multiple extraction strategies supported. So you could do a classic text extraction, get all of the text, make multiple chunks of it. Or if your documents are PDFs, if they have images, graphs, charts, then you can use layout aware, which uses vision model to identify the objects and extracts the text and indexes for you. Or it's a complex HTML page, you could use HTML aware. Or we have actually seen some of our customers creating their own extraction pipelines. In that case, you can use a custom extraction as well, right? So you connect the data sources, you extract the information, and if you have any custom enrichment pipeline, let's say all of your PDFs have too many headers, too many footers, you don't want to pollute the index, you can remove all of the noise from the documents, from this. From a vector index perspective, there are multiple models available, the default being BGEM3, but if you have your own fine-tune embedding model, you could connect that too, and you can also pick and choose on what fields you want to create the index. Now, that's the step one, you connect with, please.
Sorry, is it the PDFs are pulling from your own URLs to websites?
Yes, so you could do it from websites. You could crawl any web page. And what we also do is, even if the website is behind an authorization layer, we support that. If some of the contents of the web page are rendered dynamically using JavaScript, we support that as well. And yes. And I mean, there are 100 plus connectors, but if you have something that we don't support yet, there's always a custom connector that gets in. And especially for employee scenarios, we also support role-based access controls. So if I'm asking like, what are the tickets assigned to me, then you need to know who the user is, pass the user credentials, get only the tickets relevant to that user. So role-based access controls is available out of the box. So any knowledge base that you build here will be available to be consumed in the agent. Right? Then you have the tools, then you create multiple versions of the agents and manage. So that's how you set up your agents, similarly knowledge agent, research agent. So each project is like a use case. Inside the use case, you have multiple agents. Each of these agents is enriched with knowledge, tools. Now, last week, we also introduced memory. We always supported short-term memory. That was during the conversation. But if you would like to store preferences of the user, skip it. So the multiple ways of creating a memory, depending on what you're trying to store, you could create user-specific information that will help you personalize who the user is so that the responses will be much more contextual. Or you can have application-wide that is available for all of the agents in your project. Or you can have session level, which is available only for the current run, and then it will get wiped off. From a retention point of view, there are multiple options available. Session will be, obviously, as the name says, only for this session, or you can store for a day, a week, or a month. So that this is the long-term way of storing memory so that we can go back to memory and get the information. Please.
How is that information stored and is it shareable to other than
I think two parts to the question. So we have our own vector database plus structured database combination behind the scenes. We use Redis search and Mongo database. That's where all of that gets stored. From a retrieval point of view, we support both vector retrieval and standard JSON-based retrieval from a key value pair retrieval. Today, all of this is available only for our agents built on our platform, but they are all like independent component services. They are all powered through APIs, but we haven't thought about exposing our memory to the other agents. At the moment, it is only for us, but if you see a need, we can easily do it because, like we said, the agent protocol in the beginning, all of our components inside also use the same protocol. So there's none of these components are tightly coupled. So that's how you set your memory. Now let's try one more question. So this is a question where user says, identify all the contracts where the value is more than 250K, but for each of these contracts, get me all of the information. So for any of us, if you have to do, we probably would have to read a bunch of PDF documents, log into different systems, put all of that together, figure out the answer, right? Now, as what happens is now the orchestration engine is first calling the insights agent and asking it to do a certain task. While it does, the thoughts get streamed here so that you know what exactly is happening. Now, the insights agent is now calling the query generation tool. Again, you can double click and see the list of steps that the query generation is going through and see the full request response object. Once the first agent, which is the insights agent, has done its job, it told the manager saying that, hey, I'm done. But now the reflection happens. Now it says, hey, I need to now invoke the knowledge agent because the second part of the question requires retrieval. Now the knowledge agent goes, now it starts calling its tools. It's a RAG tool, gets the relevant information. It's calling the tool again to get more information. Now, when all of these are being done, you can see the thoughts. And the advantage is, whatever you're seeing here, everything is available as an API. So if you're building your own custom UI to expose agentic applications, and if you would like to whether stream the response, stream the thoughts, all of that will be available over the API as well. Now, once all of the job is done, the orchestration engine will reflect, say that, hey, it looks good. It starts streaming the response back to the end user. Now, because there was a RAG scenario, it also gives you a citation so that you can click and go to the original documents. So that's how you can do multi-agent orchestration seamlessly within the platform. Goes to the orchestration, invokes agents, invokes tools, reflects, and comes back with a response. Any question?
Can these user inputs can be multi-door, like other knowledge was just
Yeah, you can. Yeah, I mean, this is a full conversational, full stateful API. Right.
so basically gives call up, right?
Uh-huh.
So maybe I did not provide the value, like when the
Yeah, okay. Okay, I'll show you a quickly different example. Okay, so this is a banking assistant. I understood what it said. Let's say I want to make a payment. So it will come back and ask the question, whom do you want to send, how much do you want to send, the full stateful machine here.
and how are you planning to handle the ambiguity between two agents, specific process matching? Closer to two agents.
So there are two levels that happens. By the way, this is what happens. So here are the options that you have, like, so it does the, ask the follow-ups. One, you could, so give me 1 minute. So one, you can tune the orchestrator prompt to be more specific of picking the agent, but it won't help all the time. But when the user input has ambiguity, then it'll ask the user which one want you to do. This is exactly what's happening now. Because there are multiple agents which are doing similar things. I just said payment. I didn't mention whether it is making a transfer to a friend or making a bill payment. It'll come back and ask, hey, what do you really want to do? Yes.
So in the orchestrator, the order of the agents, does it matter? Or the order is important for the orchestrator to?
No, orchestrator is making the choice of order. Because the input has the context, depending on what the input is about, it does the plan, and then it'll start invoking the agents. So once the first agent is done, it's not guaranteed that the second agent would be called because the first agent may not have done the work correctly, so it'll call that agent again. Question? Yeah, the guy, gentleman.
From a design time setup perspective, the orchestrator has the agents. Two questions. One is the awareness of new agents coming in.
Uh-huh.
And secondly, agents. How does the orchestrator kind of, have that awareness?
So which is why the whole package as an agentic application comes into play. So this is my project finance, and these are my agents. When an agent is explicitly added, the orchestrator engine understands the profile of the agent, the tasks of the agent, because that's how the dynamically the details of the agents are passed into it. And within an agent, so the decision making happens at multiple layers. The orchestration engine need not know everything. It just needs to know what is this agent capable of. It doesn't need to know how does it do it. So how to do it is part of the agent profile. So whenever you add new skills to the agent, then the agent would understand what, how to deal them. Sorry. Yep.
One in terms of model, can you use XOGPT instead of GPT-4 or
For the dialogue GPT orchestration in the conversational assistants, we can use XOGPT. But right now, we are still researching on it because the multi-agent is slightly more complex and autonomous in nature. We tried with 5.3 model. It's fairly decent. But what we heard from Microsoft team is the 5.4 model is going to come with reasoning in it probably in June. Then we'll be in a good shape to have smaller models also doing orchestration.
The second question, you talked about contact management. Assume I have 100 contacts for a vendor.
Uh-huh.
Can I ask a question saying, hey, I need a total contact volume for this 100 vendors?
Yes. So that's where you do the SQL agent. So you do the combination of SQL and retrieval for it.
Yeah, from the orchestrator to the agent created, the digital orchestrator, is there a way to create a logic how it engages to the agent, like I'm okay doing this type of data to this agent, or this condition are met, I'll go to this agent, something like that? Or how would you handle that kind of logic?
Right. There are two approaches of doing it. One is the autonomous way of doing it. You describe all of that in the context of the orchestrator. So you define it as natural language, saying that here is what you have to do. For example, if the user is from North America, always go to this agent, or else go. So that's one way of doing it. So it's an autonomous way of doing it. The other way, if you want to implement a flow, the flow builder that we saw, you can add agents as part of the flow so that they're always executed in the same flow, same order, irrespective of what the user is saying. So there are two ways of doing it.
As far as, do you guys have any examples of like voice calls and how this works when call over? Like,
Yeah.
as far as like performance, one of our concerns is like
Okay.
how fast is the
That was a tricky question. I thought it was an easy question, but so let me go to a slide. Oops. So what we are building is just the automation capability, right? They are not consumed anywhere yet. To consume these agents, we have these three offerings: AI for work, process, and service. So banking assistant or retail assist is something that you deploy on service. When you deploy on service, we have our own native voice gateway with the ability to do a SIP trunk transfer, so that whenever a call comes to your voice gateway, it can come to us, and we take care of the automation. When we say we take care of the automation, there are two ways of doing it. The traditional way, where you do ASR and TTS, do the ASR to understand the transcript, do the automation, and generate the voice back. We also support real-time APIs, like the Google Live or OpenAI real-time API, and there are also a few open source models. There it's a multi-modal API. It's a voice to voice, so we take in voice and we generate voice back to the users. So both the options are available, but that's where you get the power of AI for service with voice gateway, channels, and everything. Did I answer the question? In terms of the latency, I mean, it's still tricky. With the traditional ASR TTS, we are seeing anywhere between 2 to 4 seconds, but with real-time API, the range is too broad. Sometimes you get anywhere between like 2 to 3 seconds. Sometimes it takes up to 10 seconds. As the models are maturing, because OpenAI's model is still in the preview mode. They have not yet made general availability, so it's hard to comment on it. But if you're going the ASR TTS routes, it's 2 to 4 seconds is what I said. Because a lot of latency is being added by the model itself. Right. So, yeah. Right, okay. I think that was a question that Naresh was asking, because we also offer fine-tuned models which can be hosted on-premise locally with us. Because these are typically 8 billion, 13 billion models, the latency is much faster with same or higher accuracy levels, but the reasoning capability is something different. So to do something like this, like an orchestration, you probably need much more capable models with lesser parameters. We are waiting for them. With 13 billion model, it's decent, but not as good as any of the commercial models.
So we have our voice orchestrator now.
Right.
Gathering intents from scripts.
Right.
Using that agent AI, can we, instead of like that model, ChatGPT, can we move our scripts to kind of, as the customer's chatting with us and we're doing the chat, look into those scripts and gather those intents and interact accordingly instead of.
Yes. So you're aware of the agent assistance capability, right?
We have agent assist, but more for like transcription summarization, not so much of the agent's tools.
No, agent assist can actually do 3 things. One, summarization, yes, but it also helps you do next best action. So it looks at what is the user saying, what is the context of the conversation, and it will suggest the live agent what is to be done. It can also generate answers. It can also perform tasks on behalf of the agent. You could also define a playbook saying that, hey, someone says, your plan is expensive, I do not want to continue. So it identifies that a particular playbook has to be run, and it starts helping the agent how to handle it. It's available today. And all of that automation capability is powered by these agents.
Yes. A bit new to this.
Sure.
When it comes to, you said the live agent,
Mm-hmm.
but when we're moving into, agentic AI and relating together,
Right.
human in the loop, how do you introduce it to that? So is it just a live agent? Because I might need any business user to decide to jump in, and because autonomous cannot be 100% for sure.
100%, yes.
You need to be a human in the loop to come
Correct.
in and do something. So how do you invoke that?
Right. So the 3 offerings, right? Work, process, and service. In case of work, it's an employee who is initiating the task. So every time before it makes a decision, it can go back to the employee saying that, hey, is my understanding correct? Because the entire orchestration is asynchronously supported. So it can wait for the user input. Only when the user says yes, it will go. In case of AI for process, it always includes multiple users, each of them doing different functions. So it will trigger action for the user to approve or reject, then it will move forward. The challenge is with AI for service. When you are interact with the end user, asking a consent from the end user will be difficult, because that's the whole point of automation, right? But once you go to agent assistance, a live agent will approve the responses that the agent is generating, only then it goes to the end user. So human in the loop as a concept is available, but how do you deploy the human in the loop concept differs whether you're doing it for work, process, or service. Did I answer the question?
Yeah.
Okay. Yes.
Just to build on the last prior question about latency, particularly in the voice channel, 2 seconds is a long time for
True.
dead air. 4, 5, 6 is really,
Correct.
unacceptable. So what, what can we offer? What can Kore
Right.
to mitigate that? I mean, I've seen what's done like in bank assist and
Okay. So
it's limited.
limited. So that's a very good question. So if you remember the demo that we are showing, the thought streaming is what actually is going to help you. Today, like say, you are a customer, you're calling me, I'm a human agent, and you have a question you asked me. When I'm looking on my system, I'll keep connecting with you saying that, hey, give me a minute, right? So that's something that agentic applications do by doing the thought streaming. So every time it's trying to do some decisioning, the thought is emitted dynamically based on the context, and you can actually play back that to the user. In Bank Assist today, there are two options, right? One, you play a music, or there's a fixed message saying that, give me a moment while I do it, but it's never contextual because the technology didn't exist.
Yeah, that's a big problem. It's not
Right.
contextual.
Right.
Same message over and over.
Now with this agentic applications, because like I said, the decisioning is broken down into orchestration, agent, and the tool. Every time you are hopping between one to other step, a contextually relevant message can be generated, which can be played back to the user. Any other questions? Okay, good. Okay. Actually, that's a question for our CEO, but I'll try and answer. So the way we are thinking is the user persona is different. The tools that you require to deploy for all of this is different. So in case of service, voice gateway, channels is extremely important. Agent assistance is important. Looking at the conversation quality in terms of the post-call analysis is important. Summarization is important. These are all the components that together will become AI for service. Right? In case of AI for work, deep integration with your knowledge sources, authorization of the user to understand who the user is, getting their profile to personalize the result, role-based access control, you allowing employees to build their own agents is all important. So in case of customer service, you don't expect your customer to build an agent, right? But in case of work, you want every individual to build their own agents to improve their productivity. So that's what AI for work is. Now AI for process is very different from these two because in both of the scenarios, there's only, the assistant is always talking to one person, either an employee or a customer. But in case of AI for process, there are multiple users coming together and it's a multi-step process. So you need to have the business workflow orchestration layer doing multiple fork and joins to complete a task. And these are all asynchronous process. You need to have the process understanding, where are the tasks pending, go and approve it. So while the automation is common, all of the tooling that you need around to go to production is extremely different from all of these three.
All right, that's helpful.
Yep.
How is the Exo platform playing?
This is Exo platform.
So the Exo platform
Is AI for service. So Exo had broadly two parts, right? The automation part of it, where you build a bot, but Exo already had contact center, agent assistance, and everything. So the automation part is moved up to the agent platform, but all of the service components are in the AI for service.
All right, so if we have the Exo platform, we have AI for service.
Yes.
So if you want to do this for AI,
I'll take the questions, but you guys are okay to stay for like 5 or 10 more minutes. We also have marketplace to be presented. I'll take a question, maybe then we'll go to marketplace, and we are around. Gentlemen.
You just mentioned orchestrate, agent, and tool.
Right.
In large companies with multiple products where you might have lots of use cases, you see that hierarchy like orchestrate, and then go to an agent, or you need to always have one orchestrator and multiple agents?
So in our experience, orchestrator handling up to 7 to 8 or 10 agents is okay. It can still take care of it. But if you have like 50 agents, it's going to be complicated. So which is why we are also introducing hierarchical patterns where you have the primary orchestrator, it picks an agent. If the agent is not able to do the task, it can delegate to the sub-agents, like a multi-step reasoning. But the challenge there is the latency because too many levels of decision. We're trying to work on it, but that's the solution to it. So we'll come back. So we'll go to the marketplace and then we'll come back and resume. Thank you. Thank you. Oh, sorry.
So we're only going to be about 5 more minutes, and then we'll stick around for more Q&A. So in the last hour and a half, Murali reviewed the building blocks of the agent platform to help you understand how you can move towards building agentic applications. And then Santosh went through how you take that extensive tooling and build agents that talk to each other and ultimately build your agentic apps. What I'm going to do is take just 5 minutes and introduce you to our Agentic Marketplace to help you get started and basically provide an entry point into the agent platform. So a few months ago, when we were starting to conceptualize our Agentic Marketplace, we had an underlying goal, which was to help our builders like yourselves evolve from building on deterministic workflows to the new agentic workflows. It's fundamentally a different way about building agentic is different from the deterministic way. And the best way for you guys to kind of know the art of the possible is to look at use cases. And so the first thing we did with the Agentic Marketplace is have basically, we've developed 300 plus use cases for you to look at what can be possible when we're thinking about agentic. The agentic paradigm really helps you unlock new use cases that weren't possible with the deterministic way of building workflows. The second pillar that we built on was making sure it was easily customizable. So if you see a template, it's quickly able to customize your business requirements, business needs, and go straight into the agent platform. And finally, we understand that everything that you're building needs to be super integrated. And so we have 300 plus integrations. And these are specific tool workflows that help you integrate what you're building into the systems that you have in your company. And we will be supporting the model context protocol as well. So as Santosh mentioned, we launched the Kore.ai marketplace last week, and it will be available for all 3 of the offerings. So if you're looking to develop use cases for your employees, we have AI for work use cases. If you're looking to build process automation use cases, you'll look into the AI for process. And then finally, of course, the customer service use cases, you'll look into AI for service. Let's take an example, because I think, as we talk about use cases in Marketplace, it might help to understand taking one example or one agentic app. So in the Marketplace, we have 3 different objects that we list all of our templates. And if we take pre-meeting prep automation, this is basically an agentic app that is used to help salespeople get a quick meeting brief before their customer meeting about the customer by giving a quick summary of all the previous conversations with that customer. So how does that work? That agentic app perhaps has 2 agents within it. One is an agenda researcher, and one is a responder agent. The agenda researcher basically gets the previous emails from Gmail, and then understands who it is from the Google Calendar. And so there's respective tools that this agent is mapped to. And then we have a Gmail tool for the responder agent. And so as a builder, you're able to start at the tool level or go install an agent or install an agentic app. Let's see what that looks like. So I'll do a quick demo of where the installing a template from the Marketplace. The Marketplace is located straight from our website. We also have it accessible from in product, but for now I'll show you from the website. So let's say I'm a product management team, and I want to equip my PMs to be able to quickly take their product or feature one-pagers and create FAQ documents to help our customer support team. So I can quickly go into the marketplace, click install, and it automatically takes me to AI for Work because this use case is for AI for Work. And as you can see, the installation process is done. It's just doing a quick review. You can go back and take a look at the purpose, the prompt. You can quickly edit it. You can modify business rules and essentially quickly publish it. So what we want to highlight here is how quickly you can start using some of these templates and get them deployed to production. Again, these are meant to be start points. You will have to go in and basically customize it to your business need. But I can show you, just how quickly we were able to get this up and running. So what I'll do is, let's say for AI for Service, we have this one-pager. I want to create some FAQ documents. Now, because I've installed this template, I, as the product manager, can quickly generate the FAQ using this agent. And so what this agent is actually spitting out right now are acknowledging some main topics and key points, and then finally giving me my output of the FAQs. I can, of course, go ahead and export this if I want to. Now, this was just a quick, simple demo to show you how you can utilize templates from our marketplace. We are going to be taking the marketplace construct forward with exposing an enterprise portal and a partner portal. So any partners in the room, you guys will have the ability to create your own templates, monetize them, and be able to generate leads coming into from other customers. For customers and enterprises, as an administrator, you can curate which templates can be used by your employees. So for example, the one I just did, you can expose that to your PM teams, et cetera, and basically have that control layer of what your employees can consume versus what they can't. And then lastly, we're also adding use case specific modules. So, I think I heard someone talk about Bank Assist, but basically all those vertical specific use cases will be listed in the marketplace as well. So almost done here. Just want to remind everyone that go check out the marketplace. You can find it if you haven't signed up for the agent platform and you're new. You can just go to the website. If you already have access to one of our platforms, it's also accessible in-app. We are working with our customers and our partners to build use cases. So reach out to me if you want, if you don't see a use case on there. Our team is more than willing to start basically populate that marketplace with more use cases.